Today we are looking at dividing monomials. So first we are going to fill out this chart to discover why certain rules work when we're dividing monomials. So 2 to the first power is 2, to the second power is 4, to the third power is 8, the fourth power is 16, to the fifth is 32, the sixth is 64, the seventh is 128, the eighth is 256, the ninth is 512, the 10th is 1024, the 11th is 2048, and the 12th is 4096. So we're going to use this to kind of make some discoveries. So first, let's calculate 2 to the 8th over 2 to the 3rd. Well, 2 to the 8th, if we look at our chart, is 256. 2 to the 3rd is 8. So if I plug into my calculator, 256 divided by 8, I get 32. What we want to make a comparison for here, is, so 2 to the 8th is 256 over 2 to the 3rd is 8. We divide that, we get 32. When we look at our chart, what is 32? 32 is 2 to the 5th power. So both of these apply, 32 and 2 to the 5th power. Let's look at the next one, 2 to the 12th, which we see right here is 4096. 2 to the 5th is 32. So if I plug that into my calculator, 4096 divided by 32, I get 128. Let's look at our chart and see what 128 represents. 128 is 2 to the 7th power. So both of these are true. And then one more example, 2 to the 10th power is 1024. 2 to the 7th is 128. When I plug that into my calculator, 1024 divided by 128, we get 8. And looking at our chart, 8 is represented by 2 to the 3rd. So let's make a comparison here. If we look at our exponents, in the first one, we have 8 and 3, and when we divide them, we get 5. Well, how do we get 5 from 8 and 3? We get it from doing 8 minus 3. Let's look at the next one. We have 12 and 5, which gives us 7. How do we get to 7 from 12 and 5? We subtract 12 minus 5. And here we have 10 and 7, and that made 3. How do we get to 3 from 10 and 7? Well, 10 minus 7 equals 3. So kind of the opposite of multiplying. Multiplying, we would add. Dividing, we would subtract. Makes sense, right? And if we think about it, if I were to write this out, 2 to the 8th power over 2 to the 3. 2 to the 8th power represents 2 times 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 2, right? There's 8 2s, 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 3rd power represents 2 times 2 times 2. If we were thinking about this in fraction form and simplifying, I could eliminate this 2. I could eliminate this 2. And I can eliminate this 2. And it leaves me with 5 2s on the top. So 2 to the 5th over 1. So a general rule is for dividing monomials, you subtract the exponents. So let's actually practice this. So our rule for dividing monomials is to divide powers with the same base, we subtract the exponents. So if I'm writing in a general rule form like we've done for everything else, 3 to the m over 3 to the n is 3 to the m minus n. So our example, a to the 14th over a to the 6th would be a to the 14 minus 6, or just a to the 8th. Practice a few basic ones. X to the 23rd over x to the 13th. 23 minus 13 is 10, so it's x to the 10th. Y to the 5th over, it's not y to the 0, most common mistake. This is y to the 1. So we're doing 5 minus 1, which is 4. And n to the 35th over n to the 8th. 35 minus 8 is 27. Now let's look at dividing monomials with numbers and variables. As I've talked about this whole unit, sometimes people start applying the exponent rules to numbers. Our numbers are just normal. We divide them or multiply them just as we normally would. So when I'm looking at 12 over 2, I'm not doing 12 minus 2. I'm making a fraction where I simplify. 12 divided by 2, or just simplify 12 and 2 to 6 over 1. Then I can look at my variable, w to the 5th over w to the 1st. 5 minus 1 is 4. So 6w to the 4th. Number 5, looking at our numbers. 24 divided by 6 divides to 4. Then looking at each variable, k to the 9th over k to the 6th, 9 minus 6 is 3. For L, 15 minus 7 is 8. And for M, 4 minus 1 is 3. Okay, 28 over 7. 28 divided by 7 is 4. F to the 12 minus 4 is f to the 8th. G to the 5th minus 1 is 4. H to the 11th minus 1 is 10. Here with our 4 to the power, since it's already written in power form, we can just leave it that way. So I'm still going to just use 4 as my base. 6 minus 3 is 3. If you wanted to actually compute that out to 64, that's fine as well. X to the 18 minus 12 is x to the 6th. Y to the 5th minus, there's no y down there, so I'm just going to rewrite that as y to the 5th. And then z to the 13th minus 4 is z to the 9th. And last one, we have this power here, okay? There's two ways that we can do this. I will show you both ways. One way is to take this power and apply it to every single part. So we would have 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 16. V, remember, to a power, 5 times 4 is 20. W to the 4 times 4 is 16. And on the bottom, V to the 4th power, 4 times 4 is 16. W to the 3rd, 3 times 4 is 12. And then we would simplify this. Our 16 stays. 20 minus 16 is 4. 16 minus 12 is 4. So that's way one. Way two would be to simplify within the parentheses first and then apply the power. So if I simplify within the parentheses, 2 stays 2. We would do 5 minus 4, which is 1, so just V. If I want to put to the first, we can. W to the 4th minus 3 is 1 as well. So this would be simplified within the parentheses, and then we apply the power of 4 to each part. 2 to the 4th power is 16. V to the 1st to the 4th power is V to the 4th. W to the 1st to the 4th power is W to the 4th. I think the second way is a little bit quicker and easier, but both of them work.